Professor Mussolini, and I'm going to teach you about ionic bonds. An ionic bond is basically two oppositely charged ions bound together by a strong electrostatic attraction. Okay, this is a classic ionic bond. The negatively charged chlorine atoms bond with the positively charged sodium atoms, forming sodium chloride. This shape is called a crystal lattice, and is very strong because all the different atoms are attracted to each other. Ionic bonds are very strong, and things like sodium chloride have a very high melting temperature because of this. You may be wondering why ionic bonds form. In order for an ionic bond to form, the difference in electronegativity of the two ions must be greater than 1.7. Now here we have Na with sodium with an electronegativity of 0.9 and chlorine with an electronegativity of 3.0. Now the difference is 2.1, so it's an ionic bond. And as you can see, 2.1 is greater than 1.7.
Wow! We have learned previously that ionic bonds are between a metal and a nonmetal, but as you can see here, there can also be two nonmetals. As you can see, fluorine has an electronegativity of 4.0 and hydrogen an electronegativity of 2.1, creating a difference of 1.9. And 1.9 is greater than 1.7, so this bond is also ionic. Now let's go see an example of ionic bonding in real life. So in this ionic bond between sodium and chlorine, sodium wants to give away its electron and chlorine wants to gain an electron. Because of the large difference in electronegativity, the electron is completely transferred from sodium to chlorine, not shared. Now sodium is a positively charged ion, and chlorine is a negatively charged ion. Now let's see an example on the board.
In the example you saw the transfer of electrons from sodium to chlorine. This equation shows the difference in electronegativity between sodium and chlorine. As you can see, the difference is greater than 1.7, making this a strong ionic bond.
We hope you enjoyed our presentation on ionic bonding.
Remember,
Nah.
Stefan, get.
This is gonna be the worst movie ever.